This week we're going to talk about a nifty little trap called a thermodynamic trap. And this is the first trap that we've looked at in this series that doesn't have any type of float whatsoever. The thermodynamic trap is using flow dynamics, the difference between the way that water and steam flow, to actuate. Basically, when condensate enters this trap, our little trap disc floats on that column of incoming water and allows the condensate to flow directly through. When steam begins to enter the trap, however, because steam is compressible and will accelerate through the trap, we'll get a low pressure zone above this opening below this disc. And that flow low pressure zone snaps that disc down. The moment it snaps down, the steam trapped in what they call the control chamber holds that trap closed until the steam in this top portion condenses, at which time it'll reopen and cycle. So this is a cycling trap. It's a great trap for steam tracing, for outdoor where there might be freeze hazards because it's basically freeze proof. It's a nice trap for drip legs and low capacity applications, maybe a unit heater. It's a pretty robust little trap. Let's take a look at how it operates with steam. So here we've got a thermodynamic trap operating as a drip leg, and what we can see right now, it's shut off. And what's happening is that cap is cooling, and when it cools sufficiently, it'll allow that trap to reopen. There we go, we get another shot of condensate. So this is an easy trap to troubleshoot because on medium to high pressure, this trap snapping closed will actually be audible over ambient noise. So it doesn't really require any special testing tools at all. We're going to talk about failure on thermodynamic traps. Of course, if a trap is cold and our valves on the inlet and outlet are open, it may be failed in the closed position. It's easy to tell if these are working because really if you're in the vicinity of the trap, you'll hear it cycle. And by cycle, I basically mean every 30 seconds to 1 minute, you'll hear the trap open, a rush of condensate, and a click or snap as the trap closes again. So if it's cold, we know we've got a problem. If it's never seeming to shut off, we could have garbage underneath the disc or something that's not allowing it to shut off properly. Another mode of failure is one that we'll see outdoors when it's exposed to cold temperatures. If this is getting rain, water, wind on it, what we'll get is a very rapid cycling of the trap because the disc is going to cycle repeatedly, and we call that machine gunning. So in some cases, you'll have a plastic cap to put over that to slow down its cycle rate. If we insulate that completely, it may close and be hours before it will reopen. So if this fails in the shut position, it's going to back condensate up until it reopens. So we're looking for a routine cycle rate that's fairly consistent.